Chemical reactions. Now, I love chemical reactions because this is the real meat of chemistry. This is where we actually see all those things that we've been putting together with the naming and forming compounds. We're going to take that information and actually be able to apply it to a laboratory situation. So before we get started, let's review real quick reactants versus products. Now, no matter what, whenever you look at a chemical reaction, you will always see it written as reactants on the left-hand side, products on the right-hand side. And this arrow in the center always means yields or forms or something along those lines. So typically when you see a reaction, you see reactants combined together to form products, or this plus this yields this. That's how you'll always know which is going to be your reactants and which are going to be your products. Your reactants are always the chemicals that react to form something new. So they are going to undergo some sort of chemical change to create a totally new product that has totally different properties than the reactants had. Your products are obviously the chemicals therefore formed from a chemical reaction. So again, as you see it, it's always written from left to right, and no matter what reaction you look at it, you always look at it from left to right. Reactants on the left, products on the right. In both situations, neither one of them have to be compounds. Now remember, a compound is a group of elements combined together to form something. So you could have elements as reactants, you could have elements as products. You could have compounds as reactants, you have compounds as products. It does not matter. So here's an example. Two elements, sodium and chlorine. Okay, as we know, we're going to combine them together and we'll form sodium chloride, table salt. So here's a situation where you have reactants on the left and products on the right. I'm sorry. And you have elements on the left and a compound on the right. Well, what if I switched it? What if I reversed the reaction and made the sodium chloride on the left and put the sodium and the chlorine on the right? Well, now I have a compound on the left and an element on the right. Does it make it an invalid reaction? No. It doesn't matter where the things are. They don't have to be the same on both. They obviously are not the same on both sides. Here's a different example. Lithium plus water. Great exothermic reaction. Take an element, combine it, put it with a compound. You get a compound, and you get another element. Okay, what if I switched it? Well, same principle. Compound, element, element, compound. Does not matter, okay? So, and again, notice the arrow is always pointing from left to right. So when I first set these up, the sodium and the chlorine were my reactants. My sodium chloride was my product. Now my sodium chloride is my reactant, and sodium and chlorine are my products. So let's complete this. Let's remember some of our naming. Quick review. Let's turn the words into formulas. So here's a reaction written out in words. Lithium metal is added to water to form lithium hydroxide and hydrogen gas. Okay, so let's do this in two ways. It says lithium is, something is added to. So it says lithium metal. Well, we know lithium from our previous screen is Li, is added to water. And of course, we know water is H2O. Resulting in, could be resulting, could be yields, could be forms. Either one. Lithium hydroxide, LiOH. Again, we know that lithium is +1, hydroxide is -1, so therefore they balance. And hydrogen gas. And of course, hydrogen we know is diatomic, or we will find out very quickly. It's diatomic. Okay? If I want to turn this into an actual chemical reaction, it would be just like the other page. Li plus H2O yields LiOH plus H2.